Hi guys, welcome back. Earlier we talked about parallel lines, so today we're going to start talking about perpendicular lines. Okay. Now, hopefully you've heard of perpendicular lines before. Okay. And perpendicular lines are lines that intersect at a 90-degree angle. Okay, so like this, and we'll have our little square there, right? And their slope is the negative reciprocal of the other. Okay, and that sounds kind of scary, but it's not that bad. So if I have a slope of 3 is really over 1. So the perpendicular slope is you flip the fraction and flip the sign. Okay, so you might want to have that written down somewhere. Okay, so I'm going to flip my fraction, so this becomes 1/3, and since it's positive, it becomes negative. Okay, so perpendicular slopes, you flip the fraction, flip the sign. So what would be the slope of this one? If the slope is -4/3, the perpendicular slope, I'm going to flip my fraction, and since it's negative, it becomes positive. So it would be a positive 3/4. Okay, so we'll practice that using some of these things. Okay, so if we have a bunch of lines and we want to decide if they are perpendicular to each other, okay, first we need to identify the slope. Okay, so if we have x equals a number, so anytime you have x equals whatever number, that will always be an undefined slope. Okay, so that means it's going up and down like this. Okay, if you have a y equals some number, that will always be a 0 slope. Okay, so in this case, it would look something like this. So since one is vertical and one is horizontal, those will always be perpendicular to each other. They will always meet at a 90-degree angle. So anytime you see an equation with x equals something and y equals something, those are automatically perpendicular to each other. Okay, let's look at these last two and see if they're perpendicular. Well, I know this one is m is -4/1. I'm just going to put it over 1 so I can decide if the fraction is flipped or not. And remember, in point slope form, this is my slope, right? So I can say m is equal to 1/4. Well, these fractions are flipped and one is negative and one is positive. So these two are also perpendicular. Okay. Let's go ahead and look at the next section here. So this one is going to have a 0 slope because we know it's y equal to something. The x one will have an undefined slope. Okay. This one would have a slope of 5/1, and this one would have a slope of -1/5. So again, I know right away that these two are perpendicular to each other. And then 5/1 is the flip of -1/5, or the negative reciprocal as we say in math terms. So those two are also perpendicular to each other. All right, if you need to pause it here to catch up, please do so. All right, so just like what we did the other day, I'm going to give you an equation, I'm going to give you a point, and I'm going to say, okay, I want the line that's perpendicular to this equation that passes through this point. So again, just like what we did with parallel, we're only using this equation to decide what my slope is going to be. Well, since it's perpendicular, this is 3/1, it's going to become 1/3, and since it was positive, it's going to become negative. Okay, so a lot of times I'll write m equals 3, and then I'll write the perpendicular slope is going to be -1/3. Okay, so if that kind of helps you keep organized, you can do that as well. Okay, so we have our perpendicular slope and then our 3, 2. So again, we're not using the m slope, we're using the perpendicular slope. So the perpendicular slope is 1/3, x equals 3, y equals 2, and b we don't know. So we're going to have y equals mx plus b. And we're going to plug in all the things that we know. So we know y is 2, we know m is -1/3, x is 3, whoops, that was not a good 3, plus b. -1/3 times 3 is going to be a -1. So we're going to get b equals 3. And again, once we know m and b, we're going to go ahead and write our new equation. So we're going to have y equals -1/3 x plus b. Okay. So again, we should have very different slopes between these two equations. And again, this first equation we're only using to steal the slope, and then we're ignoring it forever. Okay, we don't use it again. Okay, it is possible for two perpendicular lines to have the same y-intercept. That just means that's where they're crossing. Okay, but they should have different slopes. All right. Why don't you go ahead and try this one on your own and see what you get. So again, I'm looking at this equation and I see that the slope here is 5. So my perpendicular slope would be, since 5 over 1, it would be negative 1 over 5 because we flipped the fraction, flipped the sign. So again, I'm never going to use this again. So I have x, y, and b. We don't know b. We know y is 3 and x is negative 5. So we're going to plug and chug that into our wonderful formula, y equals mx plus b. We're going to have y is 3, m is negative 1/5, x is negative 5 plus b. Well, negative 1/5 times negative 5 will be a positive 1 plus b. So b is going to go ahead and equal 2 there. So my new equation is going to be y equals negative 1/5 x plus 2. Again, notice that our slopes are very different from the original equation to our new equation, but they are perpendicular to each other. All right, I think that's all for today. I hope you have a wonderful day and we'll talk to you later. Bye.